Hello, so in this video I'm going to solve one of the most famous problems in classical mechanics, the infinite Atwood machine. Let's check it out. We have a system like this. There's a pulley, a block, this pattern continues forever, and we want to calculate the acceleration of this guy. So before we start solving the problem, I want to set a notation. We call the acceleration of this first block A1, the acceleration of the second block A2, this one A3, and so on. And we call the acceleration of the pulleys A'1, A'2, A'3, and so on. And I'll call the tension of this string here T0, the tension of this string T1, this one T2, and so on. So we have the Newton's second law for one of the blocks. We have Tn minus mg is equal to man, and we have the constraint for pulleys. We have A prime n is equal to an plus A prime n plus 1 over 2. And another equation we have is that Tn is equal to T0 times 1/2 to the power of n. Because each of these tensions is half of the previous one, and we've got this equation. So let's start solving the system of equations. We can use this first and third equation to rewrite the first one as T0 times 1/2 to the power of n minus mg equal to man. What a mess. So now we've got this equation. So if I use the second equation and write it for n plus 1, I would have A prime plus 1 is equal to A n plus 1 plus A prime n plus 2 over 2. If I plug this thing inside this guy, inside this equation, what I would get is that A prime n is equal to an plus 1 plus A prime n plus 2 over 2, and the whole thing over 2. If I do this if I repeat this thing and again, what I would get is that A prime n is equal to an plus an plus 1 plus, and this thing would go forever. What a mess. So I can rewrite this thing as A prime of n is equal to an over 2 plus an plus 1 over 4 plus an plus 2 over 8 plus, and if I plug in n to be 1, if I set n to be 1, what I would get is that A prime 1 is equal to A1 over 2 plus A2 over 4 plus A3 over 8, and so on. Now we know that A prime 1, the acceleration of this pulley here, is 0, so the whole thing is 0. Now we've got this beautiful equation. A1 over 2 plus A2 over 4 plus A3 over 8, and so on, is equal to 0. So now I would use this equation and this equation to write, to simplify these equations, what I would get is 0 is equal to 1/2 times a1. I can write an as t0 over m times 1/2 the power of n minus g. I would write these t0 over m as capital A. What I would get is that 0 is equal to 1/2 times a1, which is capital A over 2 minus g, plus 1/4 of capital A over 4 minus g, and so on. If I take these g terms to the left side, what I would get is that g over 2 plus g over 4 plus g over 8 and so on is equal to a over 4 plus a over 16 plus a over 64 powers of 4. So we get a times 1/4 plus 1/16 plus is equal to g times 1/2 plus 1/4 plus and so on. These two things are geometrical series. The first one is equal to 1/3 and the second one is equal to 1. So what I would get is that a3 is equal to g. So let me clean up a little bit. So we have a3 is equal to g, and so we have a equals 3 times g. If I plug this here and set n to be 1, what I would get is that a1 is equal to 3 times g over 2 minus g, which is equal to g over 2. And that's it. I hope you enjoyed it, and see you later.